So hey guys, this is Dipesh, and in this particular video we will be implementing an artificial neural network using Python's using a Python library called as Keras. So before we begin, what you have to do is we'll download a dataset. Okay, we'll be downloading the Iris dataset, which is the same dataset that we used in uh, used in the logistic regression problem. So just type in Iris dataset and click on the second link. Okay, click on the kaggle.com link, and there you will find the dataset. Okay, so all you have to do is just download this dataset. Okay, just download this dataset and extract it on your desktop or any other folder. Okay, so I have already downloaded this. So what I will do is now we will begin creating a neural network. But the problem with neural networks is that they are very hard to train because they need a lot of computation power. Okay, so my personal favorite tool that I use to train neural networks is called as Google Colab. Okay, so just go on Google and type Google Colab. Okay, just type Google Colab and click the first tool. Okay, click the first tool. So Google Colab is basically a tool, basically a cloud Jupyter notebook. Okay, so all you have to do is just write the code. Okay, write your code using Keras and write all your Python code, and it will automatically import all the libraries for us. Okay, so we don't have to worry about exporting any libraries or anything such. Okay, all we have to do is just upload our dataset and write code, and it will automatically import everything for us in the backend. Okay, and it also provides GPU support. So the free version of Google Colab provides around somewhere around 6 to 8 gigabytes of RAM, and it also provides a good sufficient amount of time on GPU. So you can easily train a neural network for 4 to 5 hours. So when you go on Google Colab, you will see an interface like this. So all you have to do is just click on File and click New Notebook. This is very similar to Jupyter Notebook. Just think of it as a cloud version of Jupyter Notebook. Okay. So now what I will do is, also don't worry about all this code. You will find all the code on my GitHub. Just go to my GitHub profile. Just type github.com/Dipesh DM. Okay, and this will take you to my GitHub. Also, if you want to see a visualization of the visualization of this neural network, you can come to my GitHub profile and you can see this this 3D image or something. Okay, this is not created by me. I just took it from Google. Okay, but you can clearly see the neural network in 3D here. So just go to repositories and you'll find a repository name as MLDL course. Okay, you'll find the code of all the lectures here. Okay, so don't worry if you don't get it, just download the code. Don't worry if you don't understand the concepts yet, just download the code and play around on your own computer. Okay, so back to Google Colab. First thing I will do is I will rename this and I will write it as artificial neural network. Okay, and let's create some more columns, some more rows. Okay, so now what we have to do is the Iris dataset that we downloaded, we have to basically upload this dataset. Okay, so first let it connect. Okay, if you are not connected, you will see a connect sign here. Just click on that connect sign and let it connect. Okay, now it's initializing. Also, in order to check that we are using GPU, just go to runtime. Okay, and click on change runtime. So if you are not using GPU, just click on this drop down and choose GPU. Okay, just save and it will now automatically refresh the whole system. So let me just terminate this session. You will not get this error, okay? I used the Google Colab for testing purpose previously, so that's why I'm getting this error. Let me reconnect. Okay, all you have to do is just go to runtime, change runtime, and just set this runtime to GPU so that it uses GPU in the backend. Now it's connected and it's showing us the RAM memory and the disk memory. Okay, it's a very easy and it's also very convenient tool. So as students and beginners in deep learning, it is a very good starting point. Now let us what we do is just click on this symbol and click on this upload symbol. Now what we have to do is we have to upload our dataset. So this is my iris dataset. What I will do is I will click here and I will drop it here. Okay, so now I have uploaded my dataset here. Once the dataset uploaded, all you have to do is just write the code. Okay, just as if you are writing the code on your local machine. So the first thing that we'll do is we'll import NumPy and import pandas, and we'll basically read the dataset. So what we'll do is I'll do df is equal to p.read csv. Okay, and I will go and copy the path of my file. So just go to your dataset and click on the three dots and click copy path. This will basically copy the path where our dataset is located. Alright, so now all I have to do is I will do df dot head and print the first 10 rows of the dataset. Okay, so here you can see we have got 6 columns here, and what we are trying to do here is we are basically trying to do a multi-class classification. So we have the 3 classes here, 3 flower classes here. Okay, in the iris dataset, all we have to do is we have to predict which class the flower belongs, given some given data about some of their attributes like sepal length, sepal width, petal length, etc., etc. So there are 3 classes. Okay, so in order to show you all the 3 classes, what I will do is I will shuffle the dataset. So I will do df is equal to df dot sample frat is equal to 1. Now let's see. Okay, so here you can see we have shuffled the dataset, and now we can easily see all the classes. So we have iris setosa, we have iris versicolor, and we have iris virginica. Okay, so these are 3 classes that we are trying to predict. So let me again remove the random sampler. Okay, so now what we have to do is we have to separate our independent variables, and we also have to encode the target variable. Since it's in the string format, okay, we have to convert this in a numerical format. Basically we have to convert the categorical feature into its numerical format. So what I will do is firstly I will first let's do the encoding. Okay, so we'll do one hot encoding. If you have not seen the video of one hot encoding, just go and look at the logistic regression video. Okay, so again what I will do is I will do y is equal to pd dot get dummies, and I will pass it our species column. So let's see how it does. Okay, so it has successfully encoded the categorical variable into the numerical format. So we'll keep this as our y, and now we have to prepare our x. Okay, so this y is basically our dependent variable. Okay, so we are trying to predict y, and now we have to prepare x. So let's prepare x. We'll remove the id column and we'll use only the 4 relevant columns. Okay, so sepal length, sepal width, petal length, and petal width. Okay, so what I will do is I will do x is equal to df dot drop, and I will remove the ID column, as well as I will remove the species column, and also I will do access is equal to 1. Now let's print the x values. So here you can see this will be our x data set. Okay, so now now we have our x and now we have our y. Now what we have to do is we have to split our data set. So what I will do is I will do from sklearn dot model selection import train test split. Okay, so what we'll do is we will keep a 70-30 ratio. So we'll use 70% of the data for training and 30% of the data for testing. So we'll do, so the x train test split will return as x train, x test, it will return as y train, and it will return as y test. So we'll do train, test, and then split, and it will take our x and y and also our test dataset size. So we will follow a 70-30 ratio. So we'll pass 0.3, which means 30%. Now let's run it. Everything, all that we are doing here is running on cloud. Okay, it's all running on some cloud server which has GPU on it. So we don't have to worry about getting stuck because we have less computational power on or anything. So let's print our x train. And also let's print our y train. Okay, so the next thing that we have to do is we have to basically we have to create our model. Okay, so in order to create our neural network model, we'll use what we'll do is we'll use Keras library. So creating our model, more specifically we will be creating a multi-layer perceptron. So a multi-layer perceptron basically has one hidden layer. Okay, so what I will do is I'll do from Keras dot models import sequential. I will explain what this sequential means. Okay, it's very interesting, and it's also very simple to use as a beginner. Next I will do is I will use Keras dot layers import dense. Now this dense is basically dense represents our dense layer, basically means our hidden layer. Okay, so what we will do is this sequential API. Okay, this sequential API basically allows us to basically create layers of neural network in sequential manner. So what we can do is in Keras we can Keras basically allows us to stack layers of neural networks on one after another using the sequential API. Okay, so for example, let me just show you. I'll type neural network and I will do images. So we know that the neural network, okay, if you look at this architecture, we in neural network is a stack of layers, okay, one after another. So sequential API basically allows us to basically stack layers one after another. So this dense layer basically represents the hidden layer. Okay, and our inputs, okay, the x values that we will be providing, these x values are basically the input layer. Alright, so now let's run them and let's create our model. So what I will do is I will do model is equal to sequential, and now I will add the layers. Okay, add the layers to our model. So I'll do model dot add, and this dense layer basically represents a hidden layer. Okay, represents this dense layer represents one hidden layer. All right, we don't need to add the input layer, because our input layer is our input variables, our x that we will insert into the neural network. That will be the input layer. I will do as model dot add, and I will add dense. Okay, now this dense function basically takes many important parameters. So what you can do is you can directly read the documentation. So I'll write Keras dot dense. Okay, so if you do dense layer, you can see the documentation here that the dense layer basically takes many variables, but the two important variables that important parameters for us are the units and the activation function. The units basically represents how many nodes do you want in the hidden layer, you know, how many nodes do you want in the hidden layer, and the activation function basically represents what activation function do you want this hidden layer to use. Okay, so we'll pass, let's say 10. Okay, we'll use 10 let's reduce this. Okay, let's use six hidden nodes, and we'll use the activation as sigmoid. Activation as sigmoid. Okay, now this is our hidden layer. Now we have to create our output layer. So what I will do again dense, and our output layer is the neurons. The number of nodes in our output layer are dependent upon the variable, our what we are trying to predict. So you can see we are trying to predict if we are basically trying to predict the classes of the flowers here. Okay, so we have 3 classes here, which means we'll need 3 probability values. Okay, we need the probability for each class. So for example, if the class is, let's say, Iris virginica, then we want the probability for all these 3 flowers, but the probability for Iris virginica should be the highest. We want to do we'll predict in that manner. Okay, so since we have 3 classes, which means we will need 3 nodes in our output layer. So I will do as dense, and I will pass it 3, and the activation that I will use is something called a softmax. A softmax is another special type of activation function. Okay, it's very easy. You can just look up, and you once you see the formula, you will clearly get it. Well, so this is our output layer. All right. Now we have created our neural network. Okay, our neural network is complete. So this is what we have created basically is called as multi-layer perceptron. So it has one hidden layer, it has one output layer. All right. Now what we'll do is we'll not do model dot fit just like we do in sklearn. We'll do model dot compile. Okay, and what model dot compile does is, let's see the documentation. So the compile method basically takes again some important parameters. First is the optimizer. Okay, so just like gradient descent that we discussed, there are also other optimizers. So all you have to do is just pass their name here, and Keras will automatically use that optimizer. And then we have to mention our loss function and also the metric that we want to print. Okay, so what I will do is I won't mention the optimizer here, since we haven't studied any optimizer other than gradient descent. So for loss, since we have in our logistic regression video, I told you that for classification we use a special type of loss function called as categorical loss function. So we'll use that loss function here. So I'll do is categorical cross entropy. Okay. In logistic regression, we or any other classification problem, we mostly use the categorical or multi-class cross entropy as the loss function. Okay. So the next thing that I have to do is I have to pass the matrix. So while training, it will print this matrix. So I'll write accuracy. Alright, so next thing that we have to do is we have to do model dot fit, and what we have to give is we have to give it a x train and we have to give a y train. Alright, and one important thing it takes is epochs, and it also takes batch size. So don't worry about these parameters right now. Just remember, one epoch means a complete one epoch means a complete iteration over the entire dataset. Okay. So we'll keep epochs as 25 and batch size as 5. So don't worry about any of these parameters. Okay. Just remember that epochs basically means one epoch basically means a complete iteration about iteration over the data set. Okay. And batch size is basically we divide our entire data set into the batch of 5 and we send the samples in batch format. Okay. So now what we'll do is we'll run this and see how the model trains. So you can see the training has started, and you can see that it prints two important metrics. First is the loss and the accuracy. So you can see as we go forward as the training begins, the loss function basically starts decreasing. So our loss is basically decreasing, and also you can see the accuracy is increasing. Accuracy of our model is increasing. Now let's print the accuracy of our model. So what we'll do is we'll do score is equal to model dot evaluate, and we'll pass our x test and pass our y test. So let's print how prints its accuracy. So what we'll do score. Alright, so let's run it and see the accuracy of our model on test dataset. So as you can see, the second value basically represents the accuracy. Okay, so accuracy is 0.68, which means 68%. So that's still pretty good because we didn't do any tuning or anything. So just for the first time, it's still pretty good. So the next thing that we will do is we'll try to predict some values. Okay, we'll try given x, we'll try to give some x values to the model, and we'll see how if the model predicts it or not. How the model basically predicts it. So first what I'll do is I will do I is equal to model dot predict. Okay, and this predict function will basically take the x values. So also let us print some x values and y values, so we can judge from the data set itself. So what I will do is I will do df dot head. Okay, and another thing that I will do is I will do y dot head. So we can, when we pass the data set, pass our x values, we can easily evaluate them just by looking at the data set. So okay, so now what we'll do is let's pass the first value. Okay, so the first value is basically the iris certosa. Okay, the first value is iris certosa. So let's copy this value and let's pass this. Okay, so what we will get in return is we'll get an array of probabilities. Okay, so basically we will get an array with three probability values, each value basically representing probability for one class. So let's run it. Okay, so we know that the truth ground truth is iris certosa, and the first value is the first value basically represents iris certosa. So here you can see the first probability value. First probability value is the highest, which means that our model has accurately predicted the flower to be iris certosa. So this is how we basically this is basically how we create neural networks, and this is how we implement neural networks. So yeah, in the next video, what we'll do is we'll try to learn more about convolutional neural network, and after that we'll try to implement convolutional neural network in the same manner that we implemented the multilayer perceptron.